Okay, good afternoon. Welcome to MAT123 Abstract Algebra, a course offered by LD Woosley, Bethany Colleges in Makati City. Welcome, Micaela. How are you?
Afternoon.
Okay, we will continue on looking into the exercise of 1-5 and so on. And then, so that's our purpose today, to apply the concepts of subgroups on various exercises. Okay, so let's open first in a word of prayer. Father in heaven, we thank you for this day. Thank you for the opportunity where we could continue our discussion about these concepts about groups, group void, semi-group, and subgroup, and other sets. Oh Lord, I pray for your grace and mercy that we may apply this, that we may realize computational and as well as conceptual knowledge on this course. We thank you, and may you continually be glorified in our midst, even as we conduct this lesson. This is our prayer in Christ's name. Amen. All right, so we are continuing. We are referring now to exercises of 1-5. All right. Okay, we are trying to look into the subgroups. So far, we have a preliminary discussion of subgroups. And now we could apply by answering this question. Yeah, we could answer this. Exercise 1 to 6, determine whether the given subset of a complex numbers is a subgroup of the group C complex numbers under addition, under the operation of addition. So it's just a yes or a no, Micaela. No? So that's the idea for numbers 1 to 6. Okay, are you ready, Micaela? Or can you see the screen, the text? Okay, so we're looking here into subgroup of a complex number C. So number 1 is real number. Is real number a subgroup of complex number? What do you think?
Yes.
Yes, we could always test. There are 3 things that we need to test. First and foremost is the range, or I mean the associativity and the identity as well as the inverse. All of these are present in a real number under which is a subgroup of complex number, because complex is a combination of real and imaginary numbers. Okay, so that is a yes. How about number 2? Positive rational numbers.
Yes, then.
Okay, now the issue here is actually under addition is the identity element. What do you think? What's the identity element under this positive rational numbers? Again,
0.
yeah, 0. So it's not present on Q plus. It's not the set. It's not under the set. It's not close to Q plus. Therefore, it's not a subgroup. No, it's not a subgroup of the group. Okay, kasi nawala yung identity. So hindi siya, though yung identity nandun sa complex, pero identity ng Q plus or positive rational expressions does not include Q or does not include 0, therefore it's not a subgroup. Okay? So it's not. How about number 3? 7 modulo. Modulo addition. Is it a subgroup or not? 7 modulo addition. Meaning the range of integers is from 0 to 6.
Hindi po.
Bakit hindi?
Yung sa inverse.
Okay, inverse. Sige. So kung inverse, so dapat it will bring to 0. No, the sum should bring back to 0, no, para maging inverse. So modulo to, no. So ibig sabihin, magro-rotate lang siya. It will go back to 0. 1 2 3 4 5 6 7 0 again. So for instance, you have 7 or 6 plus 1 under modulo 7 addition. What is 6 plus 1?
0.
0. So kung 0 ang sagot,
Okay.
inverse ng 7 ang inverse ng 6 ang 1. Okay, may inverse siya. So there's an existing inverse, yes, there's an existing identity, and it will also pass the transitivity or associativity rather. Therefore, this is a group. 7 modulo is a group. Right, how about number 4? The set of IR, imaginary times real, of a pure imaginary numbers, including 0. Yeah, including 0. I think importante yung including 0 dyan. So purely imaginary siya, no? Wala siyang real part component, so it's not a mix of real and imaginary. For number 4. So it's true. So it's a subgroup. Okay, how about number 5? Set of pi q of a rational multiples. Rational multiples of pi. Okay. Is there an identity element? Rational number multiples of pi. So parang Cartesian plane, imagine mo. Multiples of pi siya. Okay, is there an identity element?
Hindi po ba 0 din?
0. Meron bang 0? Sa number 5.
Wala po.
Meron, wala?
Wala po.
Wala. Meron. Pi, 2 pi. What is 2 pi? Pi, 2 pi. Paikot-ikot lang ng pi, 2 pi kasi multiple of ano eh. Pi, 2 pi, 3 pi, 4 pi, etc. Pero multiples of 2 pi. And what is 2 pi? What is 2 pi? Kaya 0. Okay, yun nga lang, hindi literal na 0, but it's 2 pi, multiples of pi. One of which is 2 pi. 2 pi is complete revolution, therefore it's 0 or identity. Okay, so there is. Number 5 is a subgroup. Lastly, number 6. What can you say about this set? Number 6, the set of pi raised to n such that n element of C.
Group po.
Is it a subgroup or no? Yes or no? Obviously, is there an existing identity wherein n is an integer?
Zero po, pero
Meron bang 0? Since pi there would become a constant and that will vary on n. Assuming the value of n is 0, 1, 2, 3, 4, 5. So is there any value that will be equal to 0?
Wala po.
Wala. Therefore, it's not a group or subgroup. Okay? It's not a subgroup. Now, number 7, we are asked which of the sets of exercise 1, 1 to 6 are subgroup of a complex number, non-zero, of a non-zero complex number under multiplication. So which one among the subgroups of the non-zero complex numbers under multiplication? Saan natin pwedeng ilapat dyan? Yung, obviously, by process of elimination. So complex, ang pwede lang. So definitely 1, 2, 3 is not because it's a different category. We're looking here either 4, 5, 6. The applicability of 4, 5, 6. If instead we will change the type of numbers into C C asterisk, meaning non-zero complex numbers. So pag non-zero complex numbers, then this is under multiplication. That becomes under multiplication. So ang sagot na lang dyan, between 4, 5, and 6. Mikaela, choose.
Mm.
Okay? You choose which among 1, 2, 3, 4, 5, 6 is applied to number 7. Which of the sets of exercise 1 through 6 are subgroups of a non-zero complex under multiplication? This time, under multiplication. So there an existing identity element which is equal to 1. Is it possible for number 4 or number 6 or number 5? Hmm?
5 po.
Okay, number 5. So ginawa natin siyang multiplication. Ang tanong, ang magiging sagot niya lang, pi, 2 pi, 2 pi q, 3 pi q. There are of a rational expressions always in the factor of a rational expression. So the question is, pwede ba rin pa siyang maging non-zero complex number? We could find from this non-zero complex number the identity element. This time the identity element is equal to 1 because we're asked for multiplication. Okay, is 5 part of it? Sige, I could open 1 to 6, no? 1 to 6. So, actually, may dalawa dyan na applicable pa rin. Tanggalin na natin yung pag mahulaan mo pala kung ano, no, pag tinanggal. Pili ka lang dyan. Dalawa, Micaela. Okay? So yung number 1, hindi pwede kasi real number lang siya. Ganun din naman yung number 3. Hindi rin pwede. Real number lang siya. Pero sa rational, pwede ba magkaroon ng complex na rational? Micaela? Pwede ba maging subset yun ng complex, yung rational?
Pwede po.
Pwede. Oh. Ang tanong, nandun ba yung identity for multiplication?
One po.
Okay, yung 1. Dapat kasi ang importante ito makita mo doon sa set, Micaela. Makita mo sa set yung identity. Okay, para siya masabi. Of course, associative identity and inverse function should be also tested on the sets of the subgroup. Okay, so for Q plus positive rational, so pwede siya, no? Kasi nandiyan yung 1, multiplicative, that's your multiplicative identity. Acknowledging Michelle, Becky, salamat sa iyo. Para YouTube channel. So Q plus, what else? One more. Okay, one more set.
6 po.
Okay, number 6. Now, you will see number 6. At n is equal to 0, so that's pi raised to 0. Yun, ang 1. Nandun ang 1. That's a multiplicative identity. Alright? So, those are the answers. Okay? Now, for numbers 8 to 13, this will be part of your take-home. 8 to 13. Now, you will have a take-home for 8 to 13. Okay? So, I will not touch that. This regarding matrices. No? Yan. So, you could answer 8 to 13 as part of your take-home. Okay, let's move on. Okay, for 14 to 19, it says here, determine whether the given subset of F with the induced operation is a subgroup of the group F under addition, a subgroup of group F tilde under multiplication. So it's either a subgroup for addition and subgroup for multiplication. Okay, recalling the function, yung F tilde, alam mo yung recall natin to, Micaela, yung F tilde. Yan yung okay, so these are subgroup lectures. Okay. Okay, nawala. Nasaan na yun? Non-zero value. So yung F tilde non-zero value at every point of R. Yan, non-zero value. Actually, madaling sagutin to. Dahil pag non-zero value, so anong implication? The subset F tilde whether F was with the induced operation is a subset of group F under addition. No, yan yung ating titingnan. Okay, so non-zero value at so puro non-zero value siya, Micaela, no? Pag F tilde. As we review here. So 14, so F tilde for set of real numbers. What can you say? Obviously, it's a no because it has a non-zero values for F on every point of real numbers. So that's the definition. F tilde is a subset of F consisting of those functions that have non-zero value at every point of R. It could be both positive or negative. It's not equal to zero. Therefore, 14 is a no. For addition, yes for multiplication. Right? So it's a yes for multiplication, no for addition. How about Micaela number 15? Number 15, what can you say? Okay, Micaela, what can you say about number 15? Such that f of 1 is equal to 0. Hulog. Okay, number 15, Micaela. Okay, is it close? Is it close to addition? Number 15. All right. Ako man nawawala, ako ba? Okay, after take home, number 14, it's a no for addition, yes for multiplication. Because it's a non-zero value for every point of R. That's the definition of F tilde. No? Subset F tilde. However, for subset of all F, element of F, such that F of 1 is equal to 0. So there is a zero element existing. Therefore, for number 15, it's a yes for multiplication, but ano, it's a yes for addition, but ano for multiplication. Kasi sa halip na 1 dapat ay 0. So mayroon kang additive, mayroon kang uh, additive identity which is 0 pero wala ka namang 1. So kaya siya no for multiplication. Okay, yes for addition, no for multiplication. All right? How about 16, Micaela? This time maybe you could answer. This time f of 1 is equal to 1. Okay, no for addition, yes for multiplication, correct. Correct. How about number 17? Number 17. Here, you could chat your answer, Micaela. I wonder where is Dale? Wala pa rin si Dale. Okay, no to addition, yes to multiplication, correct. All right. About number 18. Sige, you answer 18 and 19 too. 18 and 19. Okay, answer 18 and 19 also. Okay, so 19, 18 muna, 18 for both addition. Oh, that's number 18. No? No to addition, no to multiplication, correct. How about 19? The subset of all constant function in F. Okay, so for 19, it's yes in addition, no for multiplication. It's a no for multiplication. Because the zero, all right. So anyway, let's continue. No? Sige. So 19 is a yes and a no. Okay. Okay, for number 20, it's a take home. Number 20, nine groups are given below. Give the complete list of the subgroup relation between the given groups. So you have G1 up to etc. G9. No? So I want you to have the relations. The complete list of the subgroup relations between G1 up to G9. Okay, that's a take home. Please note, Michaela, number 20. All right. Here, 21. Okay, 21. Write at least 5 elements for each of the following cyclic groups. So meaning umiikot. So there's a cyclic group here. What would be the 5 elements? For an integer has modulo 25. What would be your 5 elements? What would be the 5 elements of the set? Michaela, under that 25 modulo, under addition. Okay, so that's only for No, this time distinct, no, discrete siya, no? Discrete. So discrete. A discrete value, an exact value. Okay, the answer is, since this is 5, so you could include 0, 25, and 50 on the positive side. On the negative is negative 25 and negative 50. So those are the 5 elements of the cyclic groups. Cyclic kasi umiikot-ikot na lang siya, cyclic groups. How about letter B, under multiplication? Such as n is actually an integer. So it could be positive or negative integer. So anyway, pwede naman, it's just the listing. Pero dyan at least 5 elements, though these are infinite groups, no? So you have 4, 2, 1, 1/2, and 1/4. Okay, so that's the part of the listing. If we will continue the listing, so pwede, no? So, but this is 4, 2, 1, 1/2, 1/4. And then letter C, of course, powers of pi. We have pi raised to 0 is equal to 1. Pi raised to 1 is pi. Pi squared. And then 1 over pi and 1 over pi squared. Okay. Okay, describe all elements of a cyclic groups. Okay, Michaela? So for letter C, letter B, I repeat 4, 2, 1, 1/2, and 1/4. So those are, and you could extend that. So this at least only 5 elements. For letter C, that's 1 pi, pi squared, 1 over pi, and pi squared. 1 over pi squared. All right? All right. Okay, I hope Dale is okay, no? Di ba kayo nag-usap ni Dale, Michaela? All right? So let's look at some items here before we continue. Now let's look at the cyclic group here. No? So under here definition here, let G be a multiplicative group. So meaning groups under multiplication operation. So cyclic must be operational under multiplication, no? Where A is an element of G and H is equivalent to A raised to N such that N element of G is a subgroup D and in the smallest subgroup of G that contains A. That is, ayan, that is every group G which contains A contains all elements of H. Okay, we have some proving here. Let's move to another definition. Okay, 518. Let G be a group and let A element of G, then subgroup, etc. Under theorem 57 is a cyclic group of G generated by A, denoted by A. So there is this a generation of A, no? Generated by A. Yung subgroup, generate ng A. No? Kasi ang function niya ay powers of A, denoted by A. Now the element, dahil lang. The element of a group G generate, no, is cyclic. So the group that is generate is cyclic. Now the element A of a group G generates G if A is equal to G. A group is cyclic if there is a element of G such that the one that generates is equivalent to the group. So for instance, power of A, there is a generation of A such that there is from an integer n element of Z. No? So parang ganun yung cyclic group. So this is more on a multiplier, a multiplicative group or rather than additive group. So here, describe the elements of cyclic group generated by matrix 3002. The elements are in the form 3 raised to n, 0, 0, 2 raised to n. So there is this generation of cyclic group. So parang siya yung base, no? So ng cyclic group. All right. So let's go back to our module. Now number 22, Micaela, in 22 to 25, describe all elements of a cyclic group, no? That has a degree, second degree, composing of real numbers generated by a given 2 by 2 matrix. So what can you say? No, kapag kasi kinuha mo yung exponent niyan, or yung elements pala, no? The elements. We could see the elements there. So kaya subgroup siya, meron siyang identity. Let us first elaborate the identity. What's the identity of number 22, Micaela? What's the identity of number 22, Micaela? Okay? Chat mo na lang, Micaela, kung wala kang audio. Okay, that's the element, no? Pero identity ang tinatanong ko. Yan yung element. What is the identity of that matrix? Aside from that, that's one, and then the identity. Kasi pag hindi in-include the identity, hindi siya subgroup. Kailangan makita yung identity. So it's that one, 0, 0, negative 1, negative 1, 0, and what else? Nasahin na, ba't nawalan ka ng audio? Para madalis mong masolve sana. Okay, the identity element, Micaela. The identity element, 1001 is part. For it to become a group. No, hindi lang yan, pati yung identity kasama. Alright? So, dalawa siya. So, dalawa yung elements described. No, the 0, negative 1, negative 1, 0, and the identity element 1001. Yan. Okay, how about number 23? Okay, describe the elements. So this time, okay, sige, I will illustrate using our octave here. So for number 22, so we have two elements. course, the given element here, so kanina sinabi mo, and then of course the identity. So dalawa siya. 422. For 423, so what will be the element? The element will be in this manner. So 1, composing of identity, and then you have variability there, and then we have 0 and 1. So n could be any value, or x rather, could pertain to any values. So wala, hindi pwede pala yung x doon. Hindi pwede. But that would include x. Yan. Yan, nangyari doon. So anyway, so that would be 1, x, 0, 1. So supposedly that's the conversion to character. Hindi, mali yung ano. Hindi mai-present, but that is supposedly the case, Micaela, if you're listening, number 23. Kasi dapat maging generic yung 1 para sa identity. So where n would be of real number, so that to include 0, so pasok yung identity. Pasok yung identity doon. Alright? So for number 23, 24, so nakikita mo ba, Micaela, number 24? Number 24. Yan. Ba't walang audio mo? Anong nangyari sa audio mo? Okay, this time, what can you, how do you describe the elements of a cyclic subgroup whose element is 3002? So kasi dyan, dapat ma-generate din yung identity element. Ang mahalaga yung identity element ma-generate out of this matrix given. So that's the important thing there, no? Right? So for okay, for 24, paki-verify na lang, Micaela, no? Pawalan ka ng mic, Micaela. So 3 raised to x, supposedly 0, pero hindi ito ubra sa ano, no? Octave. 0, and then 2 raised to x. So kasi, yung x range the values of a real number. So magpo-produce din siya ng identity element. Alright? So ganyan ang kakalabasan yan. Symbolic siya, no? 3 raised to x, 0 kasi x could be equal to 0. So magiging identity element ulit siya, no? So Okay? So that's the pattern cyclic loop. Can you solve for 25, Michaela? You could type in the octave if you want. Okay, you could type your answer in the octave if you want. I'll be giving the link. Oh, yes, makapag-produce na identity element. All right. Is that your answer, Michaela? Okay, your answer is partially correct. But we need to distinguish the identity matrix from the original matrix. So for this case, that's a good idea of expressing -2 as a base. -2 as a base. Okay, for 25, so we could consider the power of x, or -2 rather. Okay, so that's the one of the root, Michaela. And the other root would be on the identity side. So forming 4 raised to n and 4 raised to n. So another is, or 4 raised to x. Yan. So yun yung dalawang Michaela, yun yung dalawang uh, characteristic element ng given matrix to make it a cyclic group. Okay, for number 26, I want you to have a take home of this. Number 26. Please take note, number 26, another take home. All right. And as well as take home na rin yung 27 to 31. I think 27 to 35. 27 to 35. Perhaps you just answer the odd numbers, 27 to 35, odd numbers. Okay, so 27, 29, 31, 33, and 35. So that would be your assignment or take home, part of the take home. All right. So here, I would demonstrate also number 36. This is one of the Kylie's table. Complete the table 525 to a group modulo 6 elements. So that corresponds to from 0 to 5, horizontal and vertical. So ganito yung sinasabi ko kanina, Michaela, no? Yung development, 5 plus 0 is, 1 plus 5 is 0. Babalik lang siya. So ganun yun, no? Kaya dito, 1 plus 2 is still 3. 3, 4, 5, 0, 1. Ito naman, 3, 4, 5, 0, 1, 2. And then 4, 5, 0, 1, 2, 3. 5, 0, 1, 2, 3, 4. So, ganun lang yung ano niya, pagkakasunod nila. No? Alright, so I think that's it. You take note also some conceptual questions. I may include that in the test. No? The conceptual questions, starting 37, etc. No? Yan, these are conceptual questions. No? So I will include that. So starting from 1-3 until 1-7, that will be your coverage. We're now in 1-5. Okay, let's move on with 1-6. So anyway, this will be your reading. Next week, we won't meet anymore, Michaela, for 1-2-3. MAT123, we will no longer have a class by next week. No? And also, I don't know if Thursday would be a holiday, Monday, Thursday, next week. The following week, next week, we won't meet. I'm not so sure, no, because that's already the introduction of finance, no? And I know it's only, the holiday is only Friday and Saturday. So I think we still meet on a Monday, Thursday. Which will be a week after next week. But next week, we won't meet because it's your reading, no? Perhaps you need ample time to review, no? With also with other courses, no? So anyway, so ayan, yung concepts also necessary. No? So I think some, if not all, of the exercises have that. Now this is the cyclic group. Perhaps I could discuss briefly cyclic group. Then we will go on with some sample problems. But 1-7 is your own readings na. So you take care, Michael, of 1-7. Okay, so this is a cyclic group. Nung nakaraan, cyclic subgroup lang yon, pero ito group talaga. We see the cyclic groups are fundamental example of groups. In some sense, all finite abelian groups are made up of cyclic groups. When you say abelian, it's a group that has commutativity. Remember the commutative property, it's abelian. So the abelian groups are made up of cyclic groups. Now recall that the order of the finite group is the number of elements in a group. So whatever the order, that corresponds to the number of elements in the group. So as definition, let G be the group and A element of G. If G is cyclic and G is a generator of A, then number one, if G is a finite in order n, then the element A is in the order n. And if G is in the infinite, then A is in the infinite order. So another theorem, every cyclic group is abelian. So meaning they have a property of commutativity. So in abelian, so that's also a cyclic group. We now state the result from number theory. The text offers the intuitive diagrammatic diagrammatic explanation, a truly rigorous proof which requires clear definition of n. So we have here a long division. I suppose you're familiar with the division algorithm, Michaela, of an integer. So you have the division in such that the number could be equivalent to this one. Okay, so MQ, Q is the quotient plus remainder. So that's the idea there, wherein, or the quotient, rather, the quotient, where 0 less than equal r less than equal m. And q is the quotient and r is the remainder. So that's the remainder theorem of integer. I suppose, Michaela, you still recall that? This is something to do with the cyclic group. That's why it was introduced there. Division algorithm for C. For example, n is 25, m is 3. So we could express n in terms of multiples of 3, such that 3 times 8 plus 1. So q and r is equal to 1. So for another example, if we have n is equal to 15, then we could have, and m is equal to 6. Now we could have negative 15 is equal to negative 6 times negative 3 plus 3. No? Notice that r is greater than equal 0. So that's the more important thing. R, or the remainder, is greater than equal to 0. Division algorithm is necessary when studying subgroups of cyclic groups. A subgroup of a cyclic group is cyclic as well. So that's another case. Okay, so we have an example here. Find the number of element cyclic subgroup of a group of a complex number, non-zero complex, under multiplication generated by 1 plus I square root over square root of 2. So the number of elements of cyclic group. So perhaps we could look into some sample problems later. No? Okay, an example here. Find the orders of the subgroups of Z20, meaning a modulo 20 integer. So this is an additive group. No, an additive group with a generator A is equal to 1, with S is equal to 2, all right? And B is equal to A raised to S, such that 2 times 1 is equal to 2, and 2 generates a subgroup in order N over D. So that's why you have D is equal to greatest common divisor of 20 and 2, which is 2, so that numerator over denominator 20 over 2 is 10. So we could see here, to produce, no? These are the following subgroups. No? Anyway, you could just read this, no? In due time. So you have generators order 1, 0. And then since this is 20, there are 2 generators of 10. 2 orders. 2 order, level 2 generators of 10. Level 4, 5, and 15. So from that, we could generate that based on utilizing your division algorithm that we have used here. No? So of course, for all prime numbers, it's order 20. For 10, so we have 2, 6, 14, and 18. For 5, it's 4, 8, 12, and 16. So those are the aspects here. And the rest would be generator Z20, order 20. I hope you're getting the point, Michaela. In solving, we are using based on the lectures here, we're using division algorithm as our prominent solution, wherein we're actually determining, for instance here, no? So if I may recall, so D is equal to GCD 20 and 2 is equal to 2. So numerator over denominator is 10. with S is equal to 4. So has an order 20 over 4, 5 elements. S equal to 5, 4 elements. S is equal to 10, 2 elements. Yan. So, yan yung mga subgroups. Okay, this is an example of the subgroup of 20. Subgroup diagram 20. So, here we go. Okay, I would answer some question on modules 6, no? So that's for have some clearer understanding as far as cyclic group is concerned. Okay, are you ready, Michaela? Let's solve some problems here on 1-6. Now, from exercise 1 to 4, find the quotient remainder according to division algorithm. So that's necessary. No? So division algorithm. So n is 42 and m is 9. So from there, so we could divide actually. Michaela, I suppose, no, I hope you could react there, both audio and text. No? So 42 and 9, you just simply divide and get the remainder. So we have 42 is equal to 9 times 4, which is 36, plus 6. So the remainder is 6. No? The quotient is 4. 4 is the quotient, and then R is 6. Okay, Michaela, can you solve for number 2? Where n is negative 42 and m is 9. Take note, R is always positive. All right? Okay, can you put there in the chat box your answer for Q and R for number 2? Okay, can you type on the chat box, Michaela, your answer? Right. Q is negative positive because n is negative 42. All right. So correct. Okay, for number 3, sige, you also solve for 3 and 4. 3 and 4. Solve for the quotient and remainder based on that division algorithm. Okay, that's it's negative 7. It's supposed to be negative 7 and 6. All right. How about number 4? You answer also number 4. Number 4 is 6 is remainder. Quotient is 6, R is 2. Okay, correct. Okay, for number 5, I think this is simple. You could answer this. Find the greatest common divisor of these integers. 5, 6, and 7. So perhaps you could solve. Or you may use octave, Michaela. You may use octave. Solve using octave. GCD 32, 24, etc. So that's how we solve for the greatest common divisor. Okay. Yeah, the answer is 8, correct? Okay, you do for 6 and 7 also. Okay, also 8, 8. Correct? Okay, the answer is 60, correct? Okay, next. Now, for number 8, it says here, find the number of generators of a cyclic group having a given order. So, what we could see here is for us to know those relative primes to that order. Meaning number 5, what is relative prime to 5 lower than 5? Now, starting from 1. Okay. So 1, 2, 3. 1, 2, 3 lang ba? Kaya na? So, yan. For number 8, is it 1, 2, 3? How about 4? O yan, sige, tama. Sige, next. Number 9. How about 8? What are numbers relatively prime to 8? So that would be the order of that cyclic group. Okay, so 1, 3, 4, 8. So tanggal yung 2, Micaela, kasi hindi siya relatively prime. Yun lang relatively prime. So 2 is not relatively prime to 8 because it has a common, ayan, noted, 1, 3, 5, 7. So order 4. Order 4 pa rin siya. How about number 10, 12? Saka yung 11 na rin, 16. So kindly solve. Okay, it's also 1, 5, 7, 11 are all relatively prime to 12. So correct. How about the last item there? List all of those who are relatively prime to 60. Okay, mahaba-haba ang listing niya doon sa number 11. So ilan lahat yan, Micaela? Anong order niya? Okay, 16. Order 16, correct. Okay, next. Isomorphism, we know that. An example of isomorphism, no? Onto one-to-one correspondence. No? So these are isomorphism of a group in itself is automorphism of a group. No? So making what must be the image of the generator under automorphism. So what is asked here are the number of generator. Okay, for number 12, so kung dalawa lang siya, 1 and 2, ano yung generator sa kanila? Pag Z2, ano yung generator sa kanila, Micaela? Okay, an example here for number 12, Z2, the answer is there are only one automorphism, which is 1. 1 is, 1 must be carried into only generator, which is 6. Which is 1 rather, 1. So 1 yung i-generate niya, 1. Okay, so that's for C sub 2. C sub 6, number 13, there are two automorphism. Now, 1 can be carried into either the generators 1 or 5. So the generators are 1 or 5 as far as Z6 is concerned. For number 14, Z sub 8, again, we will look into some of the relatively prime here. So the relative, what are the relative primes for Z8? Micaela, number 14. For Z8. Number 14. So can you enumerate those relative prime numbers under C8? All right. For C sub 2, C sub 2, C sub 2, dalawa, ay isa. Isa dahil ang generator niya 1. C sub 3 or C sub 6, ang generator niya ano? So, meron kang 1 or 5 as your generator. Okay? And then yung C sub 8, ano yung generator niya? So, ano yung maging generator niya? 1, 3, 5, 7. Alright, 1357 for Z8. Now for Z, no? For Z, so more on infinito, so it's 1 and -1. So dalawa ang generator niya. For, so we have, tinatanong dyan yung automorphism. We have 1 for Z sub 2. We have 2 for Z sub 6. We have, for Z sub 8, we have 4. And then we have for Z, we have 2. 1 and -1. And then we have, for Z sub 12, it's 4. 4 din siya, no? So anong component niya? 1, 5, 7, 11. So that's 4. Automorphism. Okay, so sige. So kailangan mo ng readings, Micaela. You may read all of the modules. No, kasi kailangan talaga 'yon. So, the concepts are clear, and then you need to practice exercises. And then yung mga dinikta natin dito, no? So similarly, your take home here will be 7 to 21. Okay. Yun na, sige. 7 to 29 na, Micaela. Take home na yan. 17 to 29. 17 to 29. Please note, 17 to 29. Halos pare-pareho lang naman yan. 17 to 29, that part of your take home of 1-6. 1-6. Kasi more concept na yung mga tanong dito. No? So, ayan. Take note sa exam, magiging multiple choice na tayo. Mas kukuha din ako sa conceptual questions. So, starting from 1-3 to 1-7. So, yan, no? So, dito hanggang 25. Hanggang 29 na yung solving mo. 17 to 29. I hope Dale could take note of this. No? Paki-chat na rin siya, Micaela, if possible, si Dale, para hindi siya nawawala, no? Actually, nawawala siya. Okay, did you note, Micaela? So halos pare-pareho lang yan, no? So kailangan lang talaga ng background reading. Alam mo sa abstract algebra, no, that's one thing that there's a need for you to read concepts kasi for an undergrad we are more computational than conceptual, no? So but for higher math in the master's level, yon, more on mas mataas na level ng computations and concepts, no? So but anyway, we're digging just on the ground, the basics of these concepts that we are dealing with. Now sa 1-7, I won't be lecturing anymore. It's part of your readings. I will just assign. So this will end our lesson today, no, as I assign for 1-7 also. So this one is how generating a Kylie group. For 1-7. So siguro mas madali itong Kylie's group na to. Yeah, mas maganda to. Okay, for 1-7, since I will no longer answer this, okay, 1 to 6, please take note, 1 to 6. 1 to 6. Okay, I want you to solve also for 7. 1 to 6 and then 7, 8 and 10. 8 and 10. Ayan, yan lang kasi yung concept naman, dyan ako I would probably get derivation, conceptual questions from these concepts, no? Oh yes, 1-7 na to, Micaela. So, so 1 to 6, 7, 8, and 10. So, ang hindi mo lang susolve doon yung 9. So, yun yung take home. That will be take home. Hindi, not necessary. Not necessary. Isasabay ko na to doon sa pagpasa ng exams. No? This will be, the deadline of the take home is the deadline of the exam. Alright, so anyway, when I create the forms, hindi ko nalalagyan ng petsa, no? Hindi ko na siya lalagyan ng petsa, but automatically that is the deadline is the same as the exam, the midterm examination. Alright? So mas madadali na yung tanong dito, no? Para move on na tayo pagdating ng finals, chapter 2 na tayo or section 8. No? So ayan. So magre-reinforce na tayo, magre-review tayo sa final exam para at least may maganda-gandang concepts ka ng abstract algebra. This will be most especially useful if you will be taking graduate school in mathematics. You have foundations in abstract algebra. But for in teaching mathematics, not yet. It's not yet hindi pa siya ganun kagamit when teaching secondary. Basically, we don't have abstract algebra. But of course, the concepts will overflow in your college algebra or your intermediate algebra in your STEM classes. All right. So I think yun lang so far. Yun na lang yung ating natitira para pagdating ng tingin ko magkaklase tayo ng Monday, Thursday. I don't know if you have a schedule. No? Let me know ahead of time if you have. Kasi ang based dun sa calendar, it's just Friday. No, Friday and Saturday, that's holiday. Monday, Thursday still has classes. But next week definitely won't meet because that would be in a way your time to read, time to review on 1-3 to 1-7, preparation to your midterm examination. Alright, so far yun lang yung okay, I think I'm done, no? So that's the entire 1-7. We just read it, no? It's ano siya? Parang siya na yung pinaka ano, no? Yung generating sets and Kylie diagram. So you could always refer to these readings. Okay, para matapos na natin yan, yung bulk na yan, and then we'll move on with chapter 2 or section 2. Not section 2, but section 6. Section 8 rather, section 8. Or 1 dash. Hindi na siya 1-8, 2-8 na siya. No, pagdating natin ng final period. Okay? Alright, so that's all. Thank you, Micaela, for dropping by. I hope you could relay, Dale, what we have discussed today. So far, kayang-kaya naman yan. Yun namang exam nyo, though I have not submitted to you. So I think commendable naman yung scores yung dalawa ni Dale. No? So anyway, as soon as we are moving on to midterm. So you will know also your scores for your prelim grade here in 1, 2, 3. Okay. So are there more thoughts, questions, Micaela, before we close? Okay, so thank you. So let's close in a word of prayer. Father in heaven, we thank you for this day. I hope and pray that you will guide Micaela on a review of this bulk topic from modules 1-3 to 1-7 of abstract algebra. This is not an easy task. Nevertheless, Lord, I hope that he will be reminded of some concepts so that he may apply it operationally on these groups, abelian groups, cyclic groups, and all of these concepts, Lord, in algebraic structures. We thank you, Lord. Glorify your name and continually guide us, even Micaela, as she will be taking midterm examinations next week. This is our prayer in Christ's name. Amen. Okay, thank you so much, Micaela. See you tomorrow. You will have your presentation on Edu 115 tomorrow. Okay? God bless you.